So, welcome to the lecture series on mathematical methods and applications. So, we have discussed about Fourier series and Fourier integrals. Now, we will come to Fourier transforms. Fourier transforms, like we did in Laplace transforms, its inverse and its applications. In a similar way, we will see what are Fourier transforms, its inverse, and what are the applications. Okay. So, Fourier transform is an integral transform which is similar to Laplace transforms. It has wide applications in many areas in engineering sciences, medicine, etc. Now, this Fourier transform is obtained from the Fourier integral in complex form. Now, what is it and how we obtained Fourier transform? Let us see. Now, what is the Fourier integral representation of function f(x)? It is nothing but 1 upon pi times integral 0 to infinity a omega cos omega x plus b omega sin omega x into d omega. So, this is the Fourier integral representation of function f(x). Now, substitute the value of a omega and b omega here. So, it is nothing but 1 upon pi integral 0 to infinity integral minus 1 plus infinity, it is ft, it is cos omega t dt and cos omega x plus integral minus plus infinity ft sin omega t into dt and sin omega x and whole with this whole with d omega. Okay. Now, this can be further written as 1 upon 2 pi integral 0 to infinity integral minus 1 plus infinity. Now, this is ft we can take common in both the from both the expressions. So, ft is common and it is nothing but cos omega t into cos omega x plus sin omega t into sin omega x, and it is dt is the first value and dt into d omega. So, this is nothing but 1 upon pi times integral 0 to infinity integral minus 1 plus infinity, it is ft, it is cos a cos b plus sin a sin b, one can easily add up. So, it is cos a minus b dt into d omega. Now, we can easily see that this function is even in omega, this function is even in omega. So, we can easily write this as, we can divide and multiply by 2. So, it is 1 upon 2 pi times integral minus 1 plus infinity ft cos omega t minus x dt into d omega. Okay, because it is even in omega. So, that is why we can multiply and divide by 2, and this we can write from minus 1 plus infinity. Now, now eta upon if you see this value eta upon pi times integral minus 1 plus infinity ft into sin omega t minus x dt into d omega. So, we can easily see that since it is odd in omega because of presence of sin omega term only here, it is odd in omega. So, this will be 0. Okay. So, if we add 0 here, so the value will not change, value will remain same. So, we can add or subtract. So, we can do it is minus 2 1 upon 2 eta 2 pi minus 1 plus infinity of this ft sin omega t minus x dt into d omega. Because this value is 0, 1 by 2 of this is also 0. So, 1 by 2 of this will be also be 0. So, if we subtract 0 from this expression, the value remain unchanged. So, now this is nothing but we can take 1 upon 2 pi common from both the sides, it is minus 1 plus infinity minus 1 plus infinity. When we take ft common, so it is cos theta minus iota sin theta. So, that will be nothing but e ki power minus iota theta. Theta is omega t minus x into dt into d omega. So, this is the complex form of Fourier integral representation. Okay. Now, if you simplify it further, so what we obtain? So, we obtain this is fx. So, fx will be nothing but 1 upon 2 pi times integral minus plus infinity minus plus infinity. It is ft e की power minus eta omega t into dt and whole multiplied by e की power eta omega x d omega. Okay. So, this we are calling as, this is a function of omega. So, suppose it is f, capital F omega. So, this we call as Fourier transform of function ft. Okay. So, Fourier transform of function ft will be given by minus infinity plus infinity ft e की power minus eta omega t into dt, which we are calling as f omega. And the inverse Fourier transform of ft of f omega, sorry, of f omega will be nothing but, now you substitute f omega here to get fx. So, that will be the inverse Fourier transform. It is 1 upon 2 pi times integral minus plus infinity f omega e की power eta omega x d omega. So, that will be the inverse Fourier transform of f omega, which is nothing but fx. Okay. So, this is how we can define Fourier transform of function ft and its inverse. Okay. Now, so this is how we can define Fourier transform of function ft and its inverse. Now, existence condition for the Fourier transform. So, following are the sufficient condition for the existence of Fourier transforms. First is, it must be piecewise continuous on minus infinity plus infinity, and f should be absolutely integrable on the x axis, that is integral minus infinity plus infinity mod ft dt should converge. So, if we have these two conditions, so that will be the existence conditions for the Fourier transforms. Now, let us find out Fourier transform of these few problems. First problem is ft is e की power minus a mod t when t lying between minus plus infinity and a is greater than 0. Now, we have to find Fourier transform of this function. So, Fourier transform of this function will be given by minus infinity plus infinity. You can see the definition, it is ft into e की power minus eta omega t into dt. Okay, this is by definition of Fourier transforms. Now this will be equal to, when t is negative, minus from 0. So, it is e की power minus plus at, and when t is positive, it remains same. Okay. Now, it is further equal to minus 0 e की power a minus eta omega into t dt plus, it is 0 to infinity e की power minus a plus iota omega t into dt. Okay. So, this can further be solved, e की power a minus iota omega t, okay, upon a minus iota omega from minus 0 plus e की power minus a plus iota omega t upon minus a plus iota omega from 0 to infinity. Now, when you simplify this, what we will get, which is the Fourier transform of ft, what we will get, it is a1 upon a minus iota omega. When it is minus infinity, 10 to minus infinity, 10 to 0. Again, when it is 10 to infinity, it is 0, and when it is 0, it will be minus plus 1 upon a plus iota omega. So, this value is nothing but 2a upon a square plus omega square, which is f omega. So, this will be the Fourier transform of this function f t. Okay. Now, Fourier transform the next problem when f t is 1. So, Fourier transform of this function, by definition Fourier transform what we have, it is minus infinity plus infinity f t e की power minus iota omega t into dt. So, this is how we define Fourier transform of function f t. Now, it is from minus 1 to plus 1 only when it is 1 into e की power minus iota omega t into dt. So, it is very simple to find this value. So, it is minus 1 upon iota omega will come here, it is e की power minus iota omega minus e की power iota omega. So, that will be nothing but minus minus plus iota upon omega e की power minus iota omega minus e की power iota omega. So, that will be the Fourier transform of this function f t. Okay. Now, Fourier transform of the next problem. So, it is again easy to find out. It has a unit step function at t equal to 0. Okay. So, Fourier transform of this function, that is e की power a t u naught t, will be nothing but minus infinity plus infinity f t e की power minus iota omega t dt. So, that will be nothing but, now unit step function at t equal to 0 is defined as, it is 1 when t is greater than equal to 1 and 0 when t is less than 0. So, that means it is when 0 to 1 it is only 1 and e की power a t e की power minus iota omega t dt. So, that will be nothing but 0 to 1 e की power minus a plus iota omega t into dt. It is minus will come here. Okay. When you integrate this, this is nothing but e की power 80 is here, e की power minus 80 is here. Okay. It is e की power minus 80. In the problem, it is e की power minus 80. It is minus, so it will be plus. So, when you integrate this, so it is e की power minus a plus iota omega t upon minus a plus iota omega from 0 to 1, from 0 to infinity. Sorry, because when t is 0 to infinity, it is 1. So, it is 0 to infinity. Okay. So, it is 0 to infinity. So, when infinity it is 0, when 0 it is 1, so it is a upon. So, this is the Fourier transform of this function. So, this is how we can find out Fourier transform of a function f t using a simple definition of f t. Now, let us see some properties of Fourier transform. The first property is it satisfies linearity property. Laplace satisfies linearity property in the same way Fourier transform also satisfy linearity property. So, that we can easily show also, because what will be the Fourier transform of a f plus b g? It will be nothing but minus infinity plus infinity a f t plus b g t into e की power minus iota omega t into d omega by the definition of Fourier transforms. So, that will be nothing but a times minus infinity plus infinity f e की power minus iota omega t into d omega plus b times integral minus infinity plus infinity g e की power minus iota omega t into d omega, which is nothing but a times Fourier transform of f t and plus b times Fourier transform of g t. So, this is the linearity property which Fourier transform satisfy, number 1. Number 2 is the shifting property. Shifting property states that if Fourier transform f t is f omega and t naught belongs to R, then Fourier transform of f t minus t naught is nothing but given by this expression. So, this also we can easily show. You see that Fourier transform of f of t minus t naught will be given by, again you apply formula minus plus infinity f t minus t naught e की power minus eta omega t into dt. So, this can be written as e की power minus eta omega t naught. You multiply and divide by this expression because this is free from t. Now, if you take t minus t naught as z, so it will be nothing but e की power minus eta t naught minus plus infinity f z, limits will not change, e की power minus eta z dz, if where z is t minus t naught. So, that is nothing but Fourier transform of f t. So, it is nothing but e की power minus eta omega t naught and Fourier transform of f t or f z. So, this is how we can obtain this shifting property. Now, let us find out inverse of these two problems, Fourier inverse of Fourier transforms. So, whenever we have e की power minus eta omega t naught, so recall shifting property. So, again we will recall the shifting property. Shifting property states that Fourier transform of f t minus t naught is nothing but e की power minus eta omega t naught into f omega, where f omega is Fourier transform of f t. Okay, this is the shifting property. Now, let us apply this property to find out the inverse of this. Now, here in the first problem, Fourier inverse of e की power minus eta omega upon 1 plus eta omega, is it so? Yeah. Now, here instead of t naught we have 1 and f omega is 1 upon 1 plus eta omega. So, if we compare these two, so t naught is 1 and f omega is 1 plus eta omega. Okay. So, the inverse of this will be given by f of t minus 1, okay, where Fourier inverse of f omega is f t. Okay. Now, what will be the Fourier inverse of this? So, we have just find that Fourier transform of e की power minus a t u naught t is nothing but 1 upon a plus eta omega. We have just find that Fourier transform of e की power minus a t u naught t is 1 upon a plus eta omega. So, here a is 1. So, that means f t is nothing but, that means Fourier inverse transform of 1 upon 1 plus eta omega will be nothing but 1 upon 1 will be nothing but, here a is 1. So, substitute a as 1, so e की power minus t u naught t. So, this is f t, and what will be f t minus 1 then? You simply replace t by t minus 1. So, that will be nothing but e की power minus t minus 1 u naught t minus 1, I mean u t minus 1. So, that will be the Fourier inverse inverse Fourier transform of this function. Okay. Now, similarly, if you want to find out Fourier inverse transform of second function, you again apply shifting property which is given by this. Here t naught is 2, okay, and the remaining expression 4 upon 4 plus omega square, 4 upon 4 plus omega square you can take as f omega, and you can find out Fourier inverse of 4 upon 4 plus omega using the previous examples which we have discussed. Okay. So, in this way we can find out Fourier transform and inverse Fourier transform of few problems. Okay. So, thank you very much.